The traveling salesman problem is one of the most famous, long-standing problems in theoretical computing. The goal of the problem is to find the shortest or least expensive path through a set of points, visiting every point along the way and making it back to the original starting point. Pause if you want to try it, because interestingly, humans are pretty intuitively good at it up to a certain point. This is kind of a difficult example one with 21 nodes. But for graphs with 10 to 20 nodes, generally people can quickly plan a route that is just 1% less efficient than optimal. The problem with solving the problem is it's what's called an NP-hard problem. As you add more places to visit, the time it takes to find a solution grows exponentially. And if you're given the correct solution, like you can with Sudoku, you can't easily check if it's the correct solution. I don't have a theoretical computational background, but basically it means it's really fucking hard for computers to solve it. Like if you try to brute force it, you have to check every city's path to every other city's path, and it's like an n factorial type thing. It's like checking every possible order that a deck of cards can be in by shuffling it out. It's just not going to happen in anybody's lifetime because there are 8 times 10 to the 67 possible combinations, which is an unfathomably large number. Like more atoms than make up the Earth, or more nanoseconds that have happened since the Big Bang. So the reason us people are somewhat good at it is that we use heuristics, or mental shortcuts, to figure it out. Like we tend to not cross paths, and we tend to connect boundary points together. So computer scientists try to find optimal algorithms, heuristics, and rules of thumb to find optimal routes, and sometimes they have breakthroughs. Probably my favorite method uses simulated ant colonies to find the best route by ants preferentially following simulated ant pheromones. And there are a bunch of other methods and aspects to it that are still way over my head.